So continuing our notes on lines, now we're going to talk about graphing lines or graphing linear functions. And these are things you know. You are actually really good at this. So when you first learn how to graph lines, do you remember them talking about solutions? What's a solution, by the way? All right, a solution is an ordered pair that works in the equation. So a lot of times we can generate numbers for x. X is all independent variable. So x can essentially be anything, but once you pick an x, then that y kind of goes with that x, or the y depends on the x. So 0 plus 5 is 5. 1 plus 4 is 5. 2 plus 3 is 5. Are those the only solutions to that line? No. How many solutions are there? Right, an infinite number of solutions, and that line represents all of those solutions. If you have something with a fraction in it, 0 is always a good thing to pick, because 0 times negative 4/3 would be 0. But maybe I'll pick a number like 3. Negative 4/3 times 3 is negative 4. 3, negative 4. Maybe another number that's easy to pick might be negative 3. Negative 3 times negative 4/3 would be positive 4. So negative 3, positive 4. Those are just 3 of the infinite solutions, but that's enough for me to graph the line. Again, this is a special one, 3 and 4, and you remember from HAVEX that these are horizontal and vertical lines. Sometimes I even like to write that this is going to be horizontal and this is going to be vertical. I can still pick any numbers for x in number 3, but the y value is always, always, always 3. So I have 0, 3, 1, 3, 2, 3. I could keep going 3. Any ordered pair would end in a 3, creating that horizontal line. In number 4, I only can choose negative 1 for x. That's my only choice. I could choose numbers for y, but they're always going to have an x value of negative 1, creating that vertical line. Now we move on to our old friend y equals mx plus b, but you'll notice that I replaced y with f of x. F of x is the same as y, and you knew that already. And what f of x represents is that this line is a function, and we are going to be using f of x more often than y. So f of x is 2x plus 3. Do you remember that the m is 2 and the b is 3? That you go up 3, from there up 2 over 1, or down 2, back 1. Y-intercept here is 1, down 2 over 1, down 2 over 1. This should be simple for us. What about the m and the b if y equals x? Right, the slope is 1, the y-intercept is 0. So 1 for the slope, up 1 over 1 from a y-intercept of 0. Where in number 8, the m is negative 1 and the b is 0. Negative slopes go down and right, or they could go up and left. If we want to graph using the intercepts, we did that earlier. I could do that again real quick. Like sometimes I make a quick table and put the 2 zeros in here. If I plug in 0 for x, I get 5 for y. Similarly, if I plug in 0 for y, I get 5 for x. So it just gives me those 2 special ordered pairs that I need to graph the line. So we did this earlier. If x is 2, if x is 0 rather, y is 2. If y is 0, x is 3. So 0, 2 is here, and then 3, 0, and then I can graph the line. A little bit trickier with horizontal and vertical lines. Sometimes I like to draw the line first and realize, okay, 0, 3 is the y-intercept, but there's no x-intercept. It never crosses the x-axis. X equals negative 1 has negative 1, 0 for the x-intercept, but there's no y-intercept, right? When we graph on the calculator, I'm just going to show you here. You're going to type in the y equals button and then type in the equation and then hit graph. And there's a lot of different zooms, so if it doesn't look like a line, you can either go to zoom standard or zoom decimal. And that will give you a picture of the line, and you can use the trace key that helps you see the ordered pairs. You can go to second table, and that helps you see that XY chart. So we'll do that in class, but you'll be able to figure that out pretty intuitively just by looking at your graphing calculator. So here is graphing linear functions.